Hey guys, welcome back to the RCA RR-359 television restoration project. We're going to pick right up where we left off in the last video. I overnighted some enameled wire we're going to use to add a filament winding to this neon sign transformer. And we're going to cut this can open, see about how we can restuff these. I reviewed projects I've done years past where I cut one of these open and other techniques online, and basically it comes down to what I surmised in the previous video, which is we're going to cut this open here. And thank you for your suggestions about different ways to cut this open. Yeah, I have used a pipe cutter in the past, and I do know about the can openers that cut around the outside rim, although I wonder, can they handle something this small, especially when this center is kind of domed out. I'm not sure if the mechanism would work out too well. But anyways, I'm going to cut this open the way I've done it in the past, which is just with a sharp box cutter, and go right in here and rock it. Not for everyone. It does take a bit of time and patience and hand strength and coordination, but this is aluminum, this is hardened steel. It goes pretty quick and it leaves a super clean thin mark. Say if I used a hacksaw or something, it would remove a bunch of material and it'd be a very jagged edge. One little thread here, and there you go. Ah, this one's filled with tar. That I haven't seen before. Yeah, it's definitely a little bit newer construction. The other ones would have had some kind of borax solution, and usually there's some blue crystals left inside and just some wiry mesh, but not a tar blob like this. Oh, yeah, there we go. So after we restuff it, oh yeah, another tip I got about doing this is take a marker and put a registration mark on both sides. So when you go to put this back on, you can get it exactly the same way it was. If you want to get that super tight seam, see, I'm kind of guessing now where exactly it went. I could clean this edge up a little bit too. So once we're done restuffing our new innards in there, got a few ways you can put this cap back on. The tutorial, I originally got this idea, he took the cap off of something and glued it to the bottom, like he took out of a 2-liter soda bottle. And yeah, actually this would be just about the right size. So if you get one that's exactly the right diameter, use hot glue contact cement, rubber cement to get that stuck in there, and then you just pop it back on and you can reopen it if you need to. So I'm going to do something along those lines as well. So yeah, you know, since this is just for demo purposes, I am not inclined to clean these insides out because I know this is not how the one that we're going to be restuffing is. So let's just put this aside. That actually went easier than I remembered it going. That aluminum is not very thick at all. Probably this can's dented too. Very easy to deform this cylinder. There you go. That's all it takes. Alright, well, let's just get to it. Let's do one of the ones I bought off Antique Radio Forum. I believe this came from an RCA radio, model 6T. That was written on there when I got it. Now, this particular radio had them insulated from the chassis, so this insulating washer down here, it's kind of stuck to it. It's made of some kind of fiber material. We don't need that, so let's get it out of the way. Boy, that's really stuck on there. Alright, so when we cut this open, you see this is a little bit different. Instead of having wires come out, it's got a rod, and then they crimped on this terminal. It's a solid, I think it's aluminum rod. We want to reuse this connector, but not so much the rod. In the past, I think I've used some 14 gauge wire that I tinned. So we'll do something similar. I'll get some brass stock, and I said we'll put some heat shrink tubing over it and then plug the remainder up with black hot glue. So I want to clean these up a bit. And grab a brush and get some of that out before we get started. I figured it'd be easier to clean while this cap is still attached to the can. Alright, that's better. While cleaning it, I noticed that quite a stress crack there on the side. I wonder if it's kind of bulging a little. I wonder if this cap was starting to fail. Just about done. I put some registration marks on there. I'm going to put it back together. A little bit holding it on. There we go. Oh, interesting. I never saw one like that with a recessed cap. Oh, I guess that goes with those two dots. I bet that's some kind of pressure release system. Cool. And that is what is inside. Insulating mesh and the anode. Should be able to pull the mesh out easily enough. It's kind of just disintegrating on me. Alright, let's get the inside out first. So to get that anode out, I do need to cut this off. And I want to salvage that connector, so I'm going to cut it down below. Alright. Oh, yeah. And that blue crystals are white in this. Yeah. I'm going to be careful of that. There's also possible there's still liquid in there. Let's see if we can just pull this out now. Yes. There we go. And there's the inside. Alright. And more crystals. Wash the inside of that out. And have ourselves a hollow aluminum tube. Alright, great. Now what? Well, this is what I initially thought I'd put in there. Oh! Maddening. It's like exactly the same diameter as the can. That ain't gonna work. Alright, so I ordered up these rectangular guys. Thought that if I bend the leads over, it'll fit. And yeah, actually, even with that bent over aluminum there, yeah, actually they do. They do. If I pushed a little bit harder, this would go in. And so when you mentioned what I can also do is cut down the casing a little bit. You can see it's potted with epoxy there. I can trim down these outer edges a little bit, whittle it down. It's not going to compromise anything. It will give me a little bit more clearance. I can probably do it on the top a bit too without causing any problems. Now I'm going to be putting two of these in, and I need to connect them in parallel, so I will need to hook up the wires. But because this is round and this is rectangular, we do have that space in there. So we can run some wires down there. We can put some heat shrink tubing over it. Let me finish whittling this down a little bit. Let's see what that gained us. Corners are a little bit thicker. And yes, I know you're supposed to always cut away from yourself. Alright, that should just go right in now. Yes. Flatten these leads out a little bit. Piece of cake. Huzzah. flash forward a few days, and some packages have arrived. I had a notion to reseal these caps with some O-rings, and it has promise, and it would work, but I need some pretty fat O-rings. Inner diameter on these is perfect. Grabs right around there, but it's not quite big enough to fit on the outside. You need an inner diameter around 20 millimeters and outer around 35, 36. So what it comes down to is the cross-section of this material needs to be 7 to 8 millimeters, which you can't commonly get. Not where I looked at, like McMaster-Carr and Amazon. What I could get is raw stock to make O-rings, where you cut it to length and you butt the ends together and glue them, but that's not exactly cheap material, and then it's going to be more work than I want to do. It's supposed to be a quick and easy solution, but oh well. Anyways, that was the idea, to do that, and oh so close. I've said that a few times, haven't I? But we'll get it sealed up. There's other options to do that, as I mentioned earlier. Alright, now I also got some brass rod to make a new terminal on the end, so this is some 8 millimeter brass stock. So that will go in there. I save the end that I cut off, and I'll carefully get out the aluminum rod from the center of that and recrimp it over this stuff. But before I do, I'll tin this up so it's not bright brass. Looked at some tin plating solution. It's expensive stuff, so I'm just going to heat this up and put some solder on it and get off as much excess as I can to make it silvery looking. And that will be that. And then, of course, we'll need to rig up 2 caps and wire them together and put it all down inside and seal it up. Of course, we can leave these open indefinitely. It's just strictly for appearance sake. Heck, we can even just leave them sitting like that, you know. It's not like it's going to be getting jostled around a lot. And of course, we can get the whole thing working before we have to worry about sealing those up. But that's the plan. Now, back to the high voltage transformer. I got a couple lengths of enameled wire. I got 22 and 20 gauge. We'll be using some of this, I expect, for making the tuner coils as well. More interestingly, I think, is I got a big box from Surplus Sales of Nebraska. It is marked Fragile, and I hope they paid attention to that when they shipped it, because there are some tubes in here. Should be all kinds of goodies in here. I wanted to fill up my order to get free shipping. If you hit $100 or more, you get free shipping with the current promotion. So I got some things I didn't strictly need for this project, but when I saw they had them, I got them. So let's see what I got, besides a mountain of peanuts that I kind of regret putting on the workbench now, but I'll deal with that later. Alright. I recently got a CTC5 working. Well, I saw they have TV tubes at Surplus Sales in Nebraska, pretty reasonably priced, probably because I don't sell very many. So I picked up some tubes for that. And I saw a few other odds and ends, like high voltage anode connectors, which I think these were like $1 or $2 each or something. So nothing else to salvage the high voltage wire, but also it's nice to get a... People ask me all the time, where do you get these? Well, Surplus Sale in Nebraska, or eBay, or scavenge them out of another old TV, computer monitor, what have you. Alright, what else? I'm curious what's in this box. I think it's a Rios. No. Oh yeah. So, color test jig. Still have to rig up cables for it, make adapters, and I saw they had this, which was also quite inexpensive. I'm pretty sure this is wired up to be an adapter between the type of CRT that was intended for and the old style. I've got a few other adapters, but this has a nice length of wire on it as well. So I figured, hey, why not? Again, I wanted to fill up the order. Let's keep going. See if we can sense that. Now this is pertinent to this project. This should be a Michael-X tube socket. Yes, it is. Oh, that's some pretty thick material too. Nice. This is what I was trying to describe. So this is 1/2 of the one from the set, and this is one I got. So yeah, it's about 30% thicker, I'd say, but very similar construction. Now, I don't think I made something very clear when I was talking about the reason why you need a high voltage socket on this is there is not high voltage between these pins. They're all at about the same potential. The other end of it that does have a big potential difference is the cap on top. No, but what you need to insulate is this has on one of the tubes about 6,000 volts and the other tube about 2,000 volts. These need to be isolated from the grounded chassis. So it's the insulation between these pins and the mounting that's important. So what I'm going to do is I got two of these, is we're going to get out a board of some sort. I'll take some ceramic standoffs and mount these tube sockets to it. We're going to rig up the filament transformer and a high voltage transformer with the filament windings added, and we're going to rig it up to these sockets, and we're going to put the rectifier tubes in there. We're going to power the whole thing up, hook up some filter caps, and see what kind of output voltages do we get. And then we're going to vary the load and see if the output voltage stays fairly constant. Those are pretty. And it's exactly the same type of very sturdy pin connectors, just like in fact they're exactly the same as the old-timey type that they used on this. Very, very, very lovely. Even if I didn't need them for this project, I wanted to get them just because they're so darn nice. You don't see stuff like that every day. And again, interesting material. Very stone-like, very ceramic-y. Alright, what else do we have? Yeah, when I was looking at the tube sockets, I saw some others that were inexpensive looking, so I ordered those up as well. I got these because I believe these will fit perfectly into a Predicta. So sometimes there's a circuit board from a 17-inch Predicta TV, and sometimes these octal sockets get worn out. I believe these should be a perfect drop-in replacement. Just kind of want to see here that the pins line up. They're spaced a little bit further apart, but I think if I straighten these out a little bit, I can make them work. Also rather inexpensive. They were less than $1 each. There's a few more things to go through. This is more pertinent to the RR-359. I think these are 7-pin sockets. Oh no, terminal strips. Oh, and sockets. I've been hunting around other tube vendor sites and eBay for tube sockets, but boy, the 7 pins, probably because they don't sell very many of them. I think these were 90 cents each. Again, not the super high quality pin connectors, the cheapo variety, but for experimenting, we can make these work. And terminal strips, which also can be kind of pricey and can be hard to find the perfect number of terminals and size that you want. These were like less than $1 each, I think. I'll some of those. Well, I hate to have to break this military sealed packaging, but we got to see what's in here. I believe this is a rheostat. A very specific purpose. Boy, how old is this? Date. Not sure how to read that. Anyway, let's keep going. We did not mess around packing this up. Geez, we've been printing on this. Now we get a date. 1987, not as old as I would have thought. Lovely, lovely. So, you've seen me work on a Dumont RA-103 chassis, or a Stromberg Carlson. There's a focus control that's very often burned out. Surplus Sale Nebraska used to sell these, which was a godsend. Nice long shaft, 25 watt, 1K, exactly what you need. They've been out of stock for these for years. This has the same ratings, just has a shorter shaft, but in a pinch I figure it's better than nothing. So I picked one up, because I do have some that are burned out or missing. that I will get to eventually. So that is what that is about. Alright, I got a little bit more to go through. This will probably be the tubes. And one of these is for the 359, the others are for the CTC5. Plus, it was just, I want to see what kind of tubes do they have, because it looked like they had some pretty nice stuff, and they very competitively priced. Alright, so this is purportedly an RCA2X2. Box has been open, which I'm not crazy about, but yeah, it's an RCA2X2A. No, they made an A version, dated from 1958. So, I have the one that came with the set, but not bad to use a new old stock, and it is RCA branded after all, so it's close to original. And then this is what I got for the CTC5. I got some later generation tubes which have integral X-ray shielding. So this is a 3A3C high voltage rectifier versus just the 3A3 I have in there right now. And I have some X-ray warnings on there. And this is a 6EL4A shunt regulator, and this is a later type, should be compatible with the one that's in there, which was a very early type. Actually, I think I have it. Yeah, here we go. So this is what was in the TV, which is a first generation 6BK4 with no thought towards shielding or anything. And I've heard that anode structure, that they welded it or something, it can be a weak point on these. Well, this is a later one. Oh yeah, and it says right on there 6BK4C, 6EL4A. I think these have leaded glass in them. You see it's quite a bit different structurally as well. So I'm going to pop both of these in the CTC5. And I believe that is it. That should be enough for us to move forward with rigging up all the high voltage transformers and rectifiers. So let's get to it. Getting back to our high voltage transformer now, put down a couple layers of Kapton tape and wrapped about 15 turns of 22 gauge enameled wire around the primary. We're going to hook up a dummy load and see where we're at. I got plenty of extra if I need to add another turn or two, but I suspect I'm going to need to remove a turn or two. And if it works well with our resistive dummy load, we're going to wire up an actual 2x2 rectifier tube and see how the filament glows on it. Alrighty, got it rigged up with a 1.5 ohm load, which should equate to 1.75 amps at 2.5 volts RMS. So here we go. 2.3. Probably need one more turn and we'll be there. Alright, that's why I left the leads extra long. Alrighty, added another turn. Let's see where we're at now. Little high. I think I will back off a turn. Well, let's see. I'm at about 117 in now, but actually our house is more like 123, 125, so that gets me to 2.7. So, yeah, let's just back off one entire turn and call this done. Alrighty, took one of the lovely Michael-X sockets I recently acquired and hooked it up. So voltmeter across it and pop in a 2x2 tube and fire it up. Now remember, this is not the rectifier for the main high voltage. This is not going to rectify the output of this neon sign transformer. It is going to rectify the output of the focus high voltage transformer, which is on the main chassis, which is around 1.5 kilovolts, so a lot less than the 6 we plan on getting out of this. That will be rectified by the much larger rectifier, which will be powered by this filament transformer. So once we're done with this little test, I'm going to seal this up with some more Kapton tape, secure everything nicely. We're going to get both of the Michelec sockets out. Going to get a breadboard, going to mount these. We're going to wire up both these transformers, both rectifier tubes. We're going to put filter caps on them and dummy loads. And eventually I'll have to wire this guy up to the high voltage transformer on the main chassis. But for now, we're just going to see if it can glow. So, here we go. Alright, sitting at just a little over 2.5 volts. And there we go. Lovely. Now, question that was asked is, did that affect the high voltage output? Let me get my high voltage probe and let's measure that with and without this tube in the socket and see if the load is draining much off of that. The hope, of course, is that it is not. Alright, let's do a little bit of a loaded test here. So I put a 4.7 meg resistor on the output of the AC, which would represent about a 1 milliamp load, and we have the 2x2 tube in the socket. Got a high voltage probe handy. Let's fire it up. So got about 2.5 on the AC filament and about 4.6 kilovolts out. Alright, now let's pop out the 2x2 and do the same thing. So remember, we had 4.6. Alright, so without that tube, we have 4.63. I mean, we're talking less than 1% difference, so I really don't think that's a concern. Now, another concern was the load on this transformer will vary between about 1 milliamp and 1.5 milliamps. So that's a 1 milliamp load. We got about 4.6 kilovolts. If I go to a 1.5 milliamp load, is that going to change much? So I'm going to throw a 10 meg resistor in parallel with the 4.7, which will simulate a 1.5, or will actually be a 1.5 milliamp load, and let's see if the output voltage changes much on it. Alright, fully loaded here. We've got the 2x2 in, we've got a 1.5 milliamp load. Let's check out the AC secondary. Alright, a tube filament, voltage is good. High voltage output, 4.51. So I believe before we did anything we had about 4.7 out. Now with this fully loaded out of the filament, we're down to 4.5. I'm not concerned. That is not much of a difference at all. So I think we're going to be just fine with this setup. Let's proceed to securing this added filament winding, and let's get out the big boy and wire up the other filament transformer, and I'll get this all arranged and more secured than this and get that high voltage wiring dressed better. I'm assembling all the components to do a little breadboarding. I've got my board, got some nice ceramic standoffs we can use with these sockets. But before we do that, really anxious to see what the big rectifier looks like. So I just wired up some power to the filament transformer we're going to be using for the big guy. Now this is the one that came with the set, which is a later generation. It's not what was in it originally. I've been told the tube that was in it originally had a thoriated filament and glows really bright, which I want to see. But let's go with this guy first. One of the charms of this set is using these early type tubes. Alright, that's plugged in. Lights a little. Wow, that's pretty bright for the later type. Now, no high voltage, it's just filament juice. So that's the tube that came with the set, so we know that's good. 2.5 volts at 5 amps. Very nice. Now, let's put in a genuine 878 tube. This is 8016, I think. 8013. Just take that guy out. Rig up this guy. Here we go. Oh, yeah, I'm seeing spots. Okay, yes, that is bright, and it instantly lights up. So, yeah, doubles as a light bulb. Isn't that pretty? That is a thoriated, directly heated filament. And you look down in there. Whoa. So the later types of tubes, they use coated filaments. But these early types, they used a special type of wire, and it was just direct. It basically is a light bulb. That's why they're so bright. Alright, so here's the plan. I'm going to put some rubber feet on the bottom of this board, flip it over, terminal strip for the AC power coming in. Going to wire up both the transformer primaries to that. We're going to mount both of these Michael X sockets on some ceramic standoffs. And we're going to wire up both the tube rectifiers. We're going to rig up a bleeder resistor network for the high voltage, and we're going to throw on some high voltage filter caps and run the thing for a while, check all the voltages, vary the load a little bit, and make sure everything is working before we commit it to the main chassis. Alright, there's 4 rubber feet. Now, if you're wondering why am I doing this, it seems like a lot of extra work. I'm just going to have to unmount all this stuff and put it in the other chassis after all. A few reasons. One, experimentation. I haven't used some of these components before, like the neon sign transformer. Educational purposes, to give you guys some idea how this rare set works. It's a bit of an unusual power supply. And just for some fun. See, in the later design, what evolved into the TRK series is they took what they had learned from making this, and they reduced the parts count. They didn't use 2 separate transformers. They used one, and they just used a 2x2 rectifier, and they used a bleeder resistor network to get the focus voltage, whereas in this they used 2 separate supplies for the focus and for the main high voltage. Speaking of high voltage, yeah, these filament wires I added will have high voltage on them, over 1000 volts. This is just enameled with some basically polyurethane over copper. I can't leave it like this. I'm not going to. What I'm going to do is take some test lead wire, the kind of stuff that comes on probes like this. I think it's good for about 5000 volts. I'm going to cut off a length. I'm going to pull out the copper wire that's in here and slide it over this enameled wire all the way down to the core. So yes, it will be insulated. Alright, so I want to arrange these so the primaries are kind of close to each other. Maybe something like that. And I'm going to mount both of these sockets on some ceramic insulators like so. And I want to leave some space to rig up 6 1 meg resistors for a bleeder on that. And I want to put some high voltage filter caps on this as well. Put one rectifier on either side. Yeah, something like that. Hey, while looking for some terminal strips for this breadboarding project, I came across another stash of vintage tube sockets, including some of the early 4, 5, 6, and 7 pin types. So I'll add that to my stash for this project. Now this video is getting long enough. I think we covered a lot of topics, from opening up a can capacitor to proving that we can indeed power a tube by adding a filament winding to this transformer, and we saw those old time early high voltage rectifier tubes lit up. Alright, so I'm going to leave off here. When we pick up, I should have this all together and we can fire it up and do some more testing with it. That's it for now. Thanks for watching.